Hi students. So today we will learn about electric charges and electric field, which is chapter number 15 of your physics textbook. Okay, so let's proceed. Let's start with the introduction. As you can see on the left side, we have the copy of the textbook, NIOS textbook. Okay, and what we see is if we start with the concept of electrostatics. So, static means something which is stationary. So, electrostatics, as it is shown on the left side text, the branch of physics that deals with electrical charges which are at rest. Okay, study of electric charges at rest. Okay, so electric charges in motion is nothing but we call it as electric current. We are not discussing that here. We are discussing the properties, the behavior of electric charges when they are stationary in this chapter. So what are we going to learn? As you can see, we need to first see what is the objective so that we can focus on whether we have learned those objectives which we started with after we end the chapter. So, what are the objectives of this chapter? First is we will understand properties of electric charge, basic properties. Okay, then we will go on to the concepts of quantization of electric charge and conservation of electric charge. Okay, we will learn what these concepts or principles are. Then we will understand Coulomb's law. So this is a very important law, Coulomb's law, which explains the force between two electric charges. It can be more than two electric charges also. So we will learn what is the force that is exerted when two charges come near each other. Then we will understand the concept of electric field and we will move on to electric dipole and what is dipole moment of the electric dipole and what is the electric field due to a dipole in two different directions, axial line and equatorial line. So these are the objectives, and then we will also understand Gauss theorem. So what is Gauss theorem and how we can derive expressions for electric field due to a point charge, due to a charged wire which is long charged wire, then due to a uniformly charged spherical shell, and finally the electric field due to a plane sheet of charge. You will understand the expressions through the Gauss theorem in each of these scenarios. And then we will these are called as applications of Gauss theorem. Okay, those derivations or expressions. Then finally we will see what is a Van de Graaff generator. Okay, so let's proceed. So now some basics about electric field and electric charges. Just read out the text. So the electric and magnetic phenomena were observed by ancient Greeks. So one of the things they did was they rubbed a piece of amber with rubber or with uh, maybe a cloth. Okay, what they found was that it is attracting small pieces of feather after being rubbed. So they understood that there is some phenomena that is happening and they coined the word electric. So in Greek language, electric means amber. And what is the meaning of that? Electron. Okay. So we can also perform some simple activities like if we run a comb through our hair which is dry, not oiled, then we see that when the comb is brought near tiny bits of paper, it attracts. The same thing when a ruler, a glass ruler we use, that also if we rub through our dry hair, it also starts attracting paper. Okay. Then there are some other phenomena like when we slide down a slide. Okay. Uh, Sometimes our hair stands. Okay. When our hand rubs against the you know side rod of that particular slide. So all these phenomena are nothing but related to frictional electricity. So two simple experiments we can perform. Let us say we take a rubber rod. This is a rubber rod. Okay. Let us rub this with wool or fur. What happens is this rubber rod becomes charged. How do we know that? Maybe it will attract tiny bits of paper. Okay. So once it is rubbed with fur or wool, if we can hold this with an insulator, okay, not directly with our hands, but with an insulator so that the charge does not get transferred. And if we are able to hang this through a thread, this is called a charged rubber rod. And we can do a similar experiment with a glass rod. And glass rod we are rubbing with silk. Okay. And after rubbing, we are again suspending it as shown. So what we notice is when we bring both these rods, charged rods near each other, they tend to attract. That means the charge developed on the rubber rod and the charge developed on the glass rod are different in nature. So by convention, scientists have said that when a rubber rod is rubbed with wool or fur, it develops negative charge, okay, on its surface. Okay. Similarly, a glass rod, when rubbed with silk, okay, it becomes positively charged. Okay, and that is why these two charges are different. So this is by convention they said that. Okay, now that's what it's saying. What is the observation is that if a charged rubber rod, okay, is brought near another charged rubber rod, let's say we have another charged rubber rod, and okay, same thing, it is rubbed with wool or fur, and that means it is having say negative charge. If this charged rod is brought near this initial charged rubber rod, we will observe that they repel. Whereas if instead of this rubber rod, we bring a glass rod near this charged rubber rod. So what is this glass rod? Charged glass rod. When glass rod is rubbed with silk, it will acquire positive charge, right? So when this charged glass rod is brought near rubber rod, they both are found to attract each other. So that's what is the observation. So by this, we have noted certain properties. What are the properties is that first thing we understand that there are two types of charges. Okay, one is called positive charge, okay, and one is called negative charge. So the charge on a glass rod when rubbed with silk is positive charge as per convention, and the charge that appears on a rubber rod when rubbed with wool is a negative charge. Okay, now second is like charges repel each other, and unlike charges attract each other. Okay, this is another thing we have found out. Okay, now Benjamin Franklin suggested that charge on glass rod after rubbing with silk be considered positive, and charge on rubber rod after rubbing with wool or fur is considered negative. Okay, that's why we follow the same convention even to date. Okay, these two are basic properties. Then we will also understand some other properties Before that, we will understand how to charge a body, electrically charge a body. What happens? Why a body is getting charged? Okay. Now, initially we have, let us say, an uncharged rubber rod. Okay, uncharged rubber rod. Now, when we are rubbing this with wool or fur, okay, this is a wool cloth or a fur. Okay, then what is happening is there is friction. Because of friction, some of the electrons of wool, which are loosely held, get transferred to the rubber rod. So the rubber rod has some excess negative charge or electrons, due to which it is behaving as a negatively charged object. And because this negative charge was initially present in wool and got transferred to the rubber rod due to rubbing, that is by friction, obviously, because those negative charges are less in the wool than initially, this wool becomes positively charged. And the amount of negative charge transferred from wool to rubber is the same amount of positive charge developed on the wool. Similarly, if we consider a glass rod and we are rubbing it with silk cloth, okay, here some of the electrons which are loosely held in the glass rod are getting transferred to silk, okay, when they are rubbed. This is because of friction. And therefore, due to deficit of negative charge, that much amount of positive charge is developed on the glass rod and an equivalent amount of negative charge is developed on the silk. Okay, this process is called charging by conduction, charging of an object by conduction. And when a charged rubber rod, let us say this is a charged rubber rod, okay, it has some negative charge and it is hung by a thread, okay, when another rubber rod which is not charged is brought in contact with this, okay, this is initially uncharged rubber rod, okay, it is brought in contact, some of the charge of the charged rubber rod gets transferred here. So let us say instead of 5, these 2 negative charges are transferred here. So this is called charging by contact or conduction again. Okay, initially it was by friction, this is by charging by contact. Now in this case, the initial negative charge is reduced because that is transferred to the uncharged rod. But note here that same kind of charge is getting transferred. Okay. Then one more way of charging is called charging by induction. So what is charging by induction? Let us say we have a rubber rod which is charged negatively and I bring a glass rod, not a rubber rod, a glass rod which is not charged, which is an uncharged glass rod near this rubber rod. So what happens in this glass rod, whatever excess electrons or loosely held electrons are there, they will get repelled by this negative charge and go to the other end of the uh, glass rod, far end, away from this rubber rod, right? And alternatively, the positive charge will develop near to the rubber rod because I have placed them close. They have not touched each other, but they are placed close. So, because glass rod is in the vicinity of rubber rod, the negative charge of some electrons which are excess in glass rod, they get shifted to the opposite side due to repulsion between the negative charge of the rubber rod and those electrons. And therefore, the positive charge will be developed near the near end of the glass rod with respect to the rubber rod. Now what will we do is we will just connect some earthing connection on the far end so that whatever negative charge is there on that near that end that gets transferred to the ground or removed from the rod. So what will happen after that is this rubber rod is having negative charge without any change. This glass rod, after removal of the negative charge through earthing, will only contain positive charge because it is still in contact with the rubber rod. So this positive charge will not flow to the ground because it is attracted by the negative charge of the rubber rod. Only the negative charge of the glass rod will flow to the earth. Okay. Now after this step, we will remove the earth and we will still be placing these rods in this vicinity. Okay. Here 6, so here also 6. That way, because the equal amount of charge. Now I have removed the earthing, only positive charge in the glass rod remains. And finally, we remove this rubber rod, only this glass rod remains. So the charge is spread uniformly on the glass rod. Now this glass rod, which was initially uncharged, has become charged. This is called charging by induction. Okay. And just for your information, if you have noticed, in the previous case of charging by friction or charging by conduction, the same charge is developed after contact. See, here charging by friction. After that, when we have connected a charged rod with an uncharged rod directly placed in contact, then same amount of charge, same type of charge is getting transferred, and also the original charge on the original rod is slightly reduced because that has transferred to the new rod. Whereas in charging by induction, first thing is opposite charge develops. If it is a negatively charged rubber rod, it is charging the glass rod with positive charge and vice versa. And secondly, there is no reduction of charge on the initial rod. Okay. So two things are happening. Opposite charge is developed and the magnitude of the original charge on the original rod is not reduced. This is charging by induction. That's what is mentioned in brief in this textbook. So charging by conduction is, as we said, once a rod or body is charged by friction, we use it to charge other bodies by touching the charged body with an uncharged body. And charging by induction is by bringing a charged body close to an uncharged body and then earthing the uncharged body's other end so that the unnecessary charge we can remove and then we can have the charge which we desire on the second conductor and charge conductor. So this way we are inducing charge on that conductor on that substance. Okay. Now we will understand one more property of electric charge, which is nothing but conservation of charge. So we understood that there are two types of charges, positive, negative. We understood that like charges repel each other, unlike charges attract each other. Now we are understanding conservation of charge. So what is conservation of charge? So if you see in the previous case, charging by friction or charging by conduction or charging by induction, whatever case you refer, let's start with charging by friction. Initially, rubber rod was uncharged, wool was uncharged. When we rubbed them together, because of friction, the charges developed. But if we consider rubber rod and wool as a system, the overall charge initially and the overall charge finally are the same. Okay. Initially, rubber rod had negative and positive charges, and it was neutral. Wool also had negative and positive charges equally, so it was neutral. When we rubbed, some of the negative charge on the wool transferred to rubber rod. Okay, but if we consider rubber rod and wool as a system, still the total negative charge of the wool is remaining same. Similarly, the rubber rod charges also will remain same if we consider it as a system, rubber rod plus wool as a system. So that's what it's saying. There is no new charge we are creating on the rubber rod. There is no destruction of charge on the wool. It's only transfer of some charge from one body in the system to the other. Therefore, a charge can neither be created nor be destroyed. That is the basic understanding of conservation of charge. Okay. And we only have found out two types of charges till date, positive, negative. There is no other kind of charge found. Now, next property after quantization is the sorry, after conservation is the quantization of charge. Now, what is quantization? Quantization means when we consider charge on a body, let us say we were drawing a charge on a rubber rod after being rubbed with, wool or fur, and I was mentioning some unit quantities like, so it is always a integral multiple. Okay, it may be 2 times, 3 times, 4 times, no, the basic charge. What is this basic charge? It is E, and its magnitude is 1.6 into 10 raised to minus 19 coulombs. Coulomb is the unit of charge. We'll learn it about it later. So any charge on any charged body is an integral multiple of this. It can be 2E, it can be 3E, it can be 100E, and so on. It can never be 2.5E. It cannot be this value. It cannot be 3.8, for example. It can be minus 2E because charges are of two types. One is positive, one is negative. So it can be minus 2E. That means 2 times the negative charge of the basic amount of charge. So that means this basic unit 1.6 into 10 raised to minus 19 coulomb is the charge on a proton. And on an electron, because we know that by convention electron has negative charge, the magnitude of charge is same, but the sign will be minus. So minus 1.6 into 10 raised to minus 19 coulomb will be that on electron. We can call it as minus C. Any charge, because a rubber rod is negatively charged, it will have integral multiple of this. A glass rod is positively charged, it can have an integral multiple of this charge, but it cannot be any non-integer value. That is the meaning of quantization of charge. Okay, so we learned that charges are of two kinds, positive, negative. Charge is conserved and charge is quantized. Let's try to answer these three questions now. Okay, what is the first question saying? A glass rod rubbed with silk acquires a charge Q is equal to plus 3.2 into 10 raised to minus 17 coulomb on a glass rod after rubbing with silk. So is the silk cloth also charged? Of course, yes. That is what we found because charging by friction. So what is the nature and magnitude of the charge on silk cloth? Because a glass rod has developed positive charge on rubbing with the silk cloth, the nature of charge on the silk is negative. Correct? Nature of charge developed on silk is negative. Short form is minus VA. Okay, you can also write negative. What is the magnitude? Of course, it is equal. Whatever positive charge has developed on the glass rod, the same amount of negative charge will be developed on the silk. So it will be minus 3.2 into 10 raised to minus 17 coulomb on silk. Okay. Now coming to the second question. There are two identical metal spheres A and B. So let us say this is a metal sphere A and this is a metal sphere B. And what is mentioned? A is given a charge plus Q. Okay. Both spheres are then brought in contact. So we have touched momentarily and then separated. Okay, and then separated again. So will there be any charge on B? Yes, through contact. Correct? So the first part of the question is, let's shorten this and write. So first part is yes, charge developed on B. What about the second part? What will be the magnitude of charge on B if it gets charged when contact with A? Now both are identical metal space, so same size, same dimensions, right? Therefore, exactly half of the charge of A will get transferred to B. So what will finally be left on A is plus Q by 2 and transferred to B is plus Q by 2. Okay, right? This is second part. Very easy. Now let's go to the third question. Third question says a charged object has Q is equal to 4.8 into 10 raised to minus 16 coulomb. How many units of fundamental charge are there on the object? We know what is the unit is 1 unit charge we understood as 1.6 into 10 raised to minus 19 coulomb. And because it is positive, so this is also some multiple of this basic positive charge. So how many magnitudes of unit charge means Is it 1e, 2e, 3e? So how many e? So let us say we write it as q equal to ne. This is the basic quantization in mathematically. N is integer. Okay. Now, in order to find out n, we can say what is n? Q by e. What was q? Q is mentioned as 4.8 into 10 raised to minus 16 coulomb divided by what is the basic unit? 1.6 into 10 raised to minus 19 coulomb. So n is a number without a unit because these two get cancelled. Now 16 threes are 48, so 4.8 upon 1.6 is 3, and this is 10 raised to minus 16 in the numerator. Now this 10 raised to minus 19 in the denominator, when we transfer it to the numerator, it will become 10 raised to 19. Now the exponent properties is that if the base is same, that is in this case 10, and we are multiplying two numbers which are exponents, then the exponents get added up. So how is it? 10 raised to minus 16 plus 19. So what is it? It is 10 raised to 3. So this 10 raised to 3. What is 3 into 10 raised to 3? It is nothing but 3 into 1000, which is 3000. So that means there are 3000 magnitude of charges, which is 3000 times the basic unit. So how many units of fundamental charge are there on the object? 3000 fundamental units. It's a fundamental charge. Agreed? So in the next video, we will understand Coulomb's law and further aspects and concepts in this chapter.